it's one thing to calculate the amount of charge an object possesses, but we need to further understand how that charge was even gained in the first place. There's three methods that we'll take a look at. The first being one of the more common, which is known as charging by friction, which is exactly what it sounds like. Charging by friction consists of taking two objects and rubbing them against one another, generating friction between the two of them. In the process of that friction occurring, electrons are being scraped from one object to the other, and that ends with one of those charges being positive, in this case this purple ball, because it gave its electrons away. If you give electrons away, you're losing your negative charges, so you become positive. And in this case, the, I guess, animal skin or cloth, whatever this is, this gained those electrons from the ball, and it now has a negative charge. So that's charging by friction in a very basic sense, but that also begs the question, how do we know which one of them gains the electrons and which one loses the electrons? Because you can't just rub two objects together and instantly know. And really that comes down to what we call the triboelectric series. So every object has its own, I guess, innate set of mechanical properties of the material that allows it to form strong bonds with electrons or weak bonds with its electrons. This is just a small portion. The real triboelectric series, I mean, if you Google it, you'll just see list after list after list. You can figure out exactly where everything falls, but a triboelectric series, or the triboelectric series, is basically a ranked list of materials in terms of how strongly or weakly they can form and hold bonds with the electrons that make up their molecules. All right, so I've kind of taken this as a general example here just to show you guys how to use this. What you want to do here is we want to realize you're going to have to take a look at how it's given. So sometimes the list is given with the weaker electron bonds at the top, going all the way down to materials that form stronger electron bonds at the bottom. Every now and then it's flipped. There doesn't really seem to be any rhyme or reason to it. So always double check the list and see whether the ones with weaker bonds are listed at the top or at the bottom, because that will change how you're going to use this list. I will typically give you the weaker materials at the top, ranked all the way down to the materials that form stronger bonds. Anyway, the easiest way to understand this is that when you can form weaker electric bonds, weaker electron bonds, you lose your electrons more easily. Okay, it's easier to rip those electrons away, and if you form strong bonds with your electrons, then you gain electrons more easily. So if I take two objects and I rub them together, they're fighting one another for the electrons, but the material that forms stronger bonds, which in this case would be those materials at the bottom of the list, those are going to rip the electrons away from materials higher up on the list because they lose their electrons more easily because they form weaker bonds with those electrons. So let's look at a few examples, and I'll try and explain exactly how we use a list like this. For example, if we were going to rub glass on cotton, we're going to look at this triboelectric series. We're going to see glass is near the top, so glass forms weaker electron bonds, and cotton is further down. It's in the middle of the list, but it's beneath glass. So comparatively, since cotton is further down on the list compared to glass, glass is going to form weaker bonds than cotton is going to form. That means if I rub these two together, when they fight for those electrons, cotton will take those electrons from glass because it forms stronger bonds. So the glass will become positive, it's going to lose its electrons, and the cotton is going to take those electrons because it forms stronger bonds with those electrons. So it all depends relatively where on this list they fall. In the second case, we'll look at cotton again, but not cotton on glass. Now we're going to look at cotton on rubber. So if you remember in example A, the glass became positive because it lost its electrons to cotton. But we have a slightly different situation here. If we look at this list, cotton is now actually the material that's higher up on the list when we're comparing it to rubber. So whereas cotton was beneath glass before and therefore took the electrons, well, rubber is actually further down the list than cotton. So now rubber is going to be the one that takes those electrons because it can form stronger bonds. So the cotton in this case becomes positive because before, while glass was above it on the list, rubber is now beneath it. And with this example list we're given, whatever is further down the list forms stronger bonds and is going to be able to rip those electrons away. Third one is going to be silk on wood. I suggest you pause the video and think about this for a second and try and figure out which becomes positive and which becomes negative, and then you can unpause, but that's certainly up to you. So if we're looking at silk on wood, silk is higher up on the list than wood is. That means that silk is going to form weaker bonds than wood is, so silk is going to lose its electrons to wood. If the silk loses its electrons to wood, it becomes positive, and if the wood is gaining those electrons from the silk, it's going to become more negative. In general, the general conditions for charging by friction, which I suggest you write down, are as follows. We generally start with two neutral objects. If they're not neutral to begin with and we allow them to make contact, they will probably transfer some electrons just by default because they have different amounts. That's a different form of charging called conduction, which we'll look at in the next video. So generally, to charge something by friction, you want to start with two neutral objects. You want to rub them together, and you will end with equal but opposite charges. And the reason for that is just like energy and momentum, electric charge is a conserved property, and it kind of makes sense because you can't create or destroy electrons. Whatever electrons one object loses are the electrons gained by the other. So if one of these objects ends with like -2 microcoulombs, the other one has to end with +2 microcoulombs because whatever electrons one of the objects gained was lost by the other object. Okay, so make sure you have these three written down. We're going to write the starting and ending conditions for all three charging methods, and these are the three steps or three conditions in order to charge by friction. And in the next video, we'll look at another example just to make sure you really understand how to use the triboelectric series to determine which object gains or loses the electrons.